question. Okay, so this is again a question which is asked by one of our students. So in case you have any doubts, feel free to get in touch with us. Okay, so you can get our contact details from our YouTube channel, or you can visit our website. All right, so let us see what this scenario is about. Okay, so the figure shows a cylindrical tube with adiabatic walls. So this entire tube which you see here, it has adiabatic walls. Okay, so it cannot exchange heat from the surrounding. So this has adiabatic walls. It is fitted with adiabatic separator. So you can see that two different places the separator is drawn. So probably separator is moved from one place to other. So this separator is also adiabatic. So once I make separator also adiabatic, then I can say that the gas on the one side will not be able to exchange heat from surrounding as well as from the other part of the cylinder. Okay, so whatever happens in one side is the adiabatic process only. Okay, so ideal gas whose gamma is given as 1.5 is injected in the two sides at equal pressures and temperatures. Okay, so let's say pressure is P naught and temperature is T naught. So this side also P naught and T naught. Okay, the separator remains equilibrium at the middle. So initially even the volume is V naught by 2, and here also it is V naught by 2. It is now slid to a position where it divides the tube in the ratio 1:3. Okay, so probably this is the initial position, position number 1, and this is the final position when the separator is moved that side. Okay, so when the separator is moved this side, this portion, let us say volume here is V1 and volume there is V2. Okay, what is given is V1 by V2 is equal to 1 by 3. Okay, so we need to find the ratio of temperatures in the two parts of the vessel. Okay, so the question asked T1 by T2. This is what? Okay, so what comes in your mind? What comes in our mind is that whatever happens this side of this cylinder is adiabatic process, and this side also it is adiabatic process only. Okay, so if that is there, and from this equation v1 by v2 is equal to 1 by 3, I can get the final volumes. How I can get? V1 divided by v1 plus v2 will be equal to 1 by 4. Okay, v1 plus v2 is v naught, right? So we have assumed that v naught is the volume of the cylinder. Okay, that is why we have written v naught by 2 and v naught by 2 initially. So v1 plus v2, no matter what is v1 or v2, v1 plus v2 will always be v naught. So v1 will be equal to v naught by 4. Okay, and v2 will be equal to 3v naught by 4. All right, so if I use at the left part, the left portion of the cylinder, adiabatic process equation, which says that T naught into the volume at that point in time, gamma minus 1 is equal to T1 multiplied by volume later point in time, that is 3v naught by 4 power gamma minus 1. Okay, this is for the left portion. Okay, let's call it equation number 1. Okay, for the right portion, I can write T naught V naught by 2 gamma minus 1 using the temperature and volume initially. This is equal to T2 into V naught by 4 power gamma minus 1. Okay, so this is equation number 2. Fine. So if I divide first equation and second equation, left hand side and right hand side, I'll get 1 is equal to T1 by T2 3V naught by 4 gamma minus 1 divided by V naught by 4 gamma minus 1. Okay, gamma is given as 1.5, right? So 1 will be equal to T1 by T2. So from there, I'll get here as root 3. Okay, so what I'll get here is T1 by T2 equals to 1 by root 3. T1 is temperature on the left side and T2 is temperature on the right hand side. Okay, so like this, we can solve this particular question. So I hope you have learned something today. In case you have any doubts, feel free to get in touch with us. Okay, thank you.